Okay, in 613, we want to talk about using the definitions we worked on in 612 and 611 and 612 with the distance formula and the definitions of parallel and perpendicular lines to talk about how to write the equation of a line that is parallel to a given line or a line that is perpendicular to a given line, and also how to find the shortest distance between a point, between a line on the graph and a random point. So, key concepts. You can write the equation of a line to a point that's parallel to a given line if you know the equation of the given line. Okay, it is necessary to identify the slope of the given equation before trying to write the equation in either parallel or perpendicular. Okay, writing equations parallel to a given line through a given point. Pause this, watch it if you need to, or read it if you need to. This is the step-by-step of what you should do. Now, I'm going to go through this on the example. I'm probably not going to use the general point slope form, which is what's given here. I probably won't be using this, but I'll show you how to do it using the slope-intercept form, which is the way that I prefer to do it. So you can use either one, though. All right, and if you want me to show you this one, just ask me in class, and I'll be happy to do so. Okay. All right. So now, if you're doing perpendicular, the key is to remember that perpendicular lines have slopes that are negative reciprocals of each other. Okay? We'll get to that when we get there, but again, you need to know what a negative reciprocal is. At this point in the year, that should not be an issue. Okay? We should know that definition. All right. We know the distance formula now. We talked about that in the last lesson, so if I'm trying to find the shortest distance, I need to draw the line perpendicular to the line in question, to the point, and then go from there. We'll get to that example in a bit, though. Common errors, some things to look out for. Pause, read through those. Things you want to try and avoid. It's too far. All right, write the slope. Write the slope-intercept form of an equation for the line that passes through the point 5, -2, and is parallel to the graph given here. So the first thing that I want to do, and this is the first thing we're going to do, is I want to get that, right, this right here, in slope-intercept form. So 8x minus 2y equals 6. We talked about this yesterday with some of the practice problems we did from the fall final that we missed. We're a little wishy-washy on how to do that. We want to move the x term first. It's positive, so I'm subtracting that. So minus 8x. What does that leave? It leaves negative 2x. So negative 2y. So that comes down. And then negative 8x is the first term, and 6 is the second term. Again, because I want to have my x out front, so it's y equals mx plus b. Okay? Now, to take care of that negative 2, because I just want it to be y equals, not negative 2y equals, I need to get rid of that negative 2, and it is connected through multiplication, so we need to divide. This is a skill, putting an equation in slope-intercept form, is a skill that ought to come as second nature to you at this point. If you are still struggling with this, we need to talk. Please ask me, okay? Because we are behind if we can't do this quickly and easily. So y equals positive 4x minus 3, okay? So I'm going to keep that in mind, and I'm going to keep this point in mind, all right? So now I'm going to go over to my next page, and I'm going to draw me a little graph, and that point was, again, just to make sure we got it, 5, -2. So that point was 5, -2. All right, so draw myself a little graph here. All right, and I need 5, -2, so 1, 2, 3, 4, 5, down 2. And then this one would go at -3 and has a slope of 4, so up 1, 2, 3, 4 over 1. Okay? All right, now I want to draw a line parallel to that, which means if you graph it, it's pretty easy because if they're parallel, they have to have the same slope. So if my slope is up 4, right 1, then I can very simply go 1, 2, 3, 4 over 1. Now, the trick is it asked me for the equation of that line. So how am I've got it graphed, but I can't see my y-intercept. So how could I use math to figure out what that y-intercept is? Well, I'm going to do this. I'm going to take that slope and that point, and I'm going to do this. Y equals mx plus b. Well, if my point is -2, my slope is 4, and my x is 5, right? Plus b, I can use that to solve for the missing piece. So that's -2 equals 20 plus b minus 20 minus 20. I got -22 equals b. So y equals 4x minus 22. And if you look at your line, it makes sense it's going to cross somewhere well below where we're currently at. Okay? And my line got a little squiggly at the end, but you get the idea. All right? So there's that. That's your final answer. All right, so let's go and look now at how you would handle one that's perpendicular. Okay? The good news is, if it's perpendicular, you only do one tiny little change. Okay? You still want to start at the same place you did before. So the first thing we're going to do is we're going to add 10x and to both sides. Okay? That's gone. I now have 5y equals 10x plus 20. About 5. Again, you should be getting to do this about as quickly as I am. There's my equation. And I know that my point that I wanted to go through is -1, 6. All right, I'm actually going to stop the video there and do the next one in the second video.